So another method that we can look at is the copy method. So let's say that we have a dictionary and we want to copy it. So make a copy demo.py. And we'll have a dictionary, and we'll do something like this. And let's say that we want to make a copy of that. We'll say y is equal to x.copy. And then let's just print x, and then we'll show the variable x, and then we'll print y, and we'll show the variable y. And let's just run that and see what we get. And we can see, yes, we get 2 copies. Now, let's do this. Let's modify x. We're going to say x password is going to equal, oops, we need to make this a string because our key is a string. And we'll set it equal to that, and then we'll display the 2 again, and just to show which one, we'll say this is before change, and then this one I'll put a \n so that we have a carriage return between the 2 after change. And we can see that these are indeed 2 separate copies. So we're not just saying y equals x. Watch what would happen if we did that. If we just said y equals x and we did this, I'm going to comment out the rest of this. So now if I just said this equals x, what will happen is if I say y equals x with this dictionary and then I change one of them, note that I just made one change to x, it actually changes both of them. If instead I do this and I make a copy of that dictionary, I'm actually making another dictionary in memory and pointing y at that second one. And that's why in this instance we're able to change the first one with this code here, but we don't modify the second one. So when you want a separate independent copy, you use the copy command. The issue doesn't change there though. There's one other interesting element though, is let's say we add another element in here. We'll say machines, and we put and so we've got these we now have another element, another key value pair, the key machines, and then we have this, but this one's value is a list with 3 elements in it. And what we're going to do is we'll do that, but we'll also say x machines dot remove bar. So we're going to modify the password here, but we're also going to remove this one from X and watch what happens. So when we modified the password in X, it modified X's password. But when we removed an element from this list, it removed it in both of them. And why is that? Well, again, it's this idea that a variable is often really a pointer. And in this case, this value is actually pointing to this list in another part of memory. And the result is that when we make just a regular copy, you end up having both X and Y are pointing at this common list. So even though the first level elements are in a completely separate copy here, both of these still point to this list that are at another place in memory. And therefore, when you change the list in one, it changes it in the other. Often this isn't a big problem. You don't really, especially if this is a tuple and you're not really modifying it that much. But if you do need these machines to be separate, well, then this doesn't work very well. So what we have to use then is a deep copy. So I'm going to make another demo. I'm going to call this deep copy demo. And I'm going to copy this code over. And what we're going to do is we're going to import a library that allows us to do this. And we're going to say from copy import. Copy is a library or a module. We're going to import the deep copy command. And we're going to change this to deep copy. Of X. It's actually done this way. So it's not a method, it's actually a function which you pass the dictionary in. And what this will do is it'll iteratively go through all the elements and make sure that you have complete separate copies. So when I run this one now, notice that this one now, we made changes to X, but it doesn't make any changes to Y. And even the list stays unchanged because now Y has its own copy of this list and X has its own copy of this list. So when do you use deep copy and when do you use copy? Well, and why do we have this behavior and why do we have these differences? Well, it turns out that doing a deep copy uses this iterative process that actually takes a lot more processing power. And so it is computationally expensive to use deep copy, whereas a regular copy is actually not that intensive. So most of the time you should probably try to use just a regular copy when you need a copy. And actually, if you, in fact, let me make another sample piece of code here. I'm going to call it pointer copy demo. And so, the other one that we did was like this, where we just said y equals x. And so when we do this, we're not really making a copy at all. We are just pointing y at the same dictionary. If we modify anything in x, if you use this, it will also modify y. If you use the copy, if you modify anything that just has a single element as its value, these will not modify the other element. But if you have a list as the value, a modification to one will modify the other. And then the deep copy demo, everything is fully independent. So if this will work, do this, because this takes less memory and less processing power. However, if you really need a copy and everything is just kind of at one level, then the copy would work. And if you really need like multiple layers of sequences inside of sequences, you know, have a complex data structure and you really need them to be independent, then you use the deep copy. So those are the copy methods for dictionaries. Thank you.